Dear students, how are you? Today we are going to discuss very easiest and simplest problem from calculus and linear algebra. Before we are going to proceed this problem, kindly subscribe this channel, share this video to your friends. So let us start the problem. Find the equation of evolutes of the curve x squared by a squared plus y squared by b squared is equal to 1. See this problem. We are given ellipse. We are going to find a new equation called evolutes, isn't it? Very simple. Just listen to me. Okay, so this is the solution. The parametric form of the ellipse: x is equal to a cos t, y equal to b sin t. Already we know this. Okay, let us start dx by dt. It means differentiate with respect to t, x as well as y, isn't it? So dx by dt equal to minus a sin t. Similarly, dy by dt equal to b cos t. Y dash equal to dy by dx. So it is a parametric form, so that dy by dt by dx by dt is equal to minus b cos t by a sin t. So this is the first thing. Okay. Okay. Next one, to find y double dash. So y double dash equal to d squared y by dx squared is equal to d by dt of dy by dx of dt by dx, isn't it? So d by dt as it is, and then dy by dx already we know, y dash minus b cos t by a sin t. So 1 by dx by dt, isn't it? So if you keep dt by dx, we don't have any answer, so that it's reciprocal 1 by dx by dt. So d by dt minus b cos t by a sin t. What about dx by dt? So 1 by minus a sin t. Okay, now I'm going to, this is differentiate the bracket term, isn't it? So cos t by sin t will be cot t, and then the last term minus 1 by a sin t capacities. So after differentiating minus b by a cot t with respect to t, it will become b by a, and then cosecant square t, and then minus 1 by a sin t. So already we know the differentiation of cot t is equal to minus cosecant square t, isn't it? Okay, let us move to the next one. Okay, this is the next thing. Y squared, y double is equal to minus b by a square into cosecant square t into 1 by cosecant t. So already we know sin t can be written as 1 by cosecant t. Simplify y double is equal to minus b by a squared cosecant cube t, isn't it? So this is the answers for y dash and y dash. This is a way to find these two things. Now let us move, write the center of curvature. So capital X can be written as small x minus y dash, y plus y dash the whole square by y double dash. Similarly, capital Y is equal to y plus 1 plus y dash square by y double dash. So these are the two curvatures, x and y. So please remember, my dear students. Okay, let us move the next one. So these are the things. It means capital X is equal to small x, right, as it is, and then replace y dash minus b cos t by a sin t, 1 plus y dash squared b squared cos squared t by a squared sin squared t, divided by y double dash minus b a squared cosecant cube t. So I take the denominator into numerator, it's a reciprocal form. So keep x as it is, and then b minus into minus. There are three minus, you know. So here one minus, here one minus, here one minus. So there are three minus. So keep minus as it is. So b cos t by a sin t, and then the denominator becomes a squared by b cosecant cube t into 1 plus b squared cos squared t by a squared sin squared t, isn't it? And then I replace x by a cos t. Already we know the parametric form of the ellipse. And then simplify, we got cos t by sin t into a by 1 by sin cube t. Cosecant cube t can be written as 1 by sin cube t. And then the last term write as it is. And then a cos t, and then simplify sin and sin cube, it becomes sin squared. So it goes to numerator. So a cos t sin squared t, and then all the term write as it is. Okay. Then So x cos t minus a cos t sin square t, and then a cos t sin square t into b squared cos square t by a squared sin square t. So I'm going to multiply the terms, isn't it? So the earlier term already we know this is the term. So we have multiply, we got three terms, and then keep first term as it is, and then second term is also keep as it is. Last term we can cancel, isn't it? So a squared sin squared everything cancel. So we get minus b squared by a cosecant cos cube t, and then a cos t take outside, so 1 minus sin squared t minus b squared by a cos cube t. So a cos t into cos squared t minus b squared by a cosecant cos cube t, and then cos cube t take outside. So a cos cube t a minus a b squared by a. So multiply, simplify, we got this is, isn't it? Thank. Okay, let us start to find the next one. Okay, y, this is y. So capital Y is equal to y plus 1 plus y dash squared by y double dash. So b sin t 1 plus b squared cos squared t by a squared sin squared t by minus b cosecant t by a squared. So this is b sin t a squared b cosecant t into 1 plus b squared cos squared by a squared sin squared t. So which is equal to a sin t minus a squared sin cube t by b. So that cosecant can be written as 1 by sine, so it goes to numerator, and then the rest of the terms write as it is, isn't it? And then b sin t a b sin t minus a squared sin cube t by b minus a squared sin cube t by b into b squared cos squared t by a squared sin squared t, isn't it? And then b sin t minus a squared sin cube t by b sin t cos squared t. So and then simplify. So 1 minus cos squared t can be written as sin squared t minus a squared sin cube t by b. So it becomes sin cube t into b into a squared by b. Okay, then then it will become y sin cube t can be written as b squared minus a squared by b. So capital Y is equal to minus sin cube a squared minus b squared by b. And then this is equation number 2. So raise 2 by 3 on both sides. So x power 2 by 3 cos cube t 2 by 3 a squared minus b squared by a 2 by 3 cos squared t can, so a squared minus b squared 2 by 3, and then a by 2 by 3. Okay, then this is a cube a power 2 by 3 x power 2 by 3 cos square t a squared minus b squared 2 by 3, and then ax 2 by 3 cos square t into a squared minus b squared 2 by 3. So similarly we are going to raise 2 by 3 on both sides. So y 2 power 3 minus sin cube t 2 by 3, and then a squared b squared by b 2 by 3. So sin squared a squared b squared 2 by 3 b per 2 by 3, isn't it? So now we are getting this one by sin square t a square 2 by 3, isn't it? So there are three equations, 3 and 4. So add these two equations. I got ax whole power 2 by 3 plus by 2 by 3 is equal to cos square t a square minus b square 2 by 3 sin square. And then I can take a square minus b square 2 by 3 outside. It will be cos square t plus sin square t. And the left side ax whole power 2 by 3 plus by 2 by 3 is equal to a square minus b square 2 by 3, and then cos square t plus sin square t will be 1, already we know. So this is the required evolute of the given ellipse, isn't it? So this is the way you can find the evolutes. Okay, so if you have any doubt, any queries, put it in the chat box. Thank you, my dear friends.